Megan.
And I'm Elizabeth.
And we're here at the NPL,
or the National Physical Laboratory.
Here in the UK, they are responsible for all things to do with measurement.
The NPL is the National Measurement Institute, and we are here to tell you about SI units. SI stands for System International. There are 7 SI units, and they can be used to derive all other measurements. They are all linked.
In 1875, 17 countries came together to create the Treaty of the Meter in Paris.
These countries signed a treaty to set the international standards for the metric system.
France holds the international standards for measurement.
When the standards were made, they were sent around the world.
And every 10 years, everyone comes together to check their standards against the originals.
Imagine a world without standardized units.
We found this film in the archive. Let's take a look.
As you can see, life without standardised units is ridiculous. Let's look at the modern system we use today.
Let's start with length.
Did you know that the first ever measurement came from Egypt?
Yeah, the cubit was the distance from the pharaoh's elbow to the tip of his middle finger.
As you can guess, it was not very accurate. It ranged from 43 to 53 centimetres depending on the pharaoh at the time.
The metre was defined in the 18th century to be 10 to the minus 7 times the length of the meridian through Paris from the equator to the North Pole. This had an 0.5 millimetre uncertainty.
The prototype of the metre was made of platinum and iridium. The uncertainty was 0.2 micrometres. The original is housed in Paris, but there is also one at the NPL.
The current definition is 1 metre equals the distance travelled by light in a vacuum in 1 second, divided by 299,792,458. This had an uncertainty of 0.1 nanometres.
The kilogram is equal to the international prototype of the kilogram, or the IPK. It is made of an alloy of platinum and iridium and is kept at the International Bureau of Weights and Measures in France. But the kilogram is being redefined. This is the Avogadro sphere. It is the new prototype for the kilogram.
The second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the 2 hyperfined levels of the ground state of the cesium-133 atom.
Wait a minute, that sounds really complicated.
It is, but luckily we have this clock. This is the most accurate clock in the world.
Cool. What time is it now?
It's going too fast. Just take a look.
Let's talk about temperature.
You're probably familiar with Fahrenheit and Celsius.
What you may not be familiar with is Kelvin.
Lord Kelvin did not like the idea of minus degrees.
So he decided to invent his own system using no minus numbers.
What he did was find the coldest temperature possible where all particles stopped moving and said that was absolute zero. Zero Kelvin.
1 Kelvin is 1 degree Celsius, but 0 Kelvin is the same as minus 273.15 degrees Celsius.
Let's talk about moles. This is the unit of substance.
1 mole will contain 6 times 10 to the power of 23 units of that substance. So if you are looking at a pure element, 1 mole of the substance will have 6 times 10 to the power of 23 atoms.
It's impossible to count that many atoms, but luckily there is a link between mass and moles. For example, 12 grams of carbon-12 will have 1 mole of carbon atoms.
The same is true of molecules or any other substance.
This number is called Avogadro's constant. It was discovered by Amedeo Avogadro, and because it applies to everything, it is a constant.
The amp is the SI unit for current. Constant current ideally would be measured with 2 wires of infinite length, 1 metre apart, in a vacuum. The force between the conductors would be equal to 2 times 10 to the minus 7 newtons per metre of length, so we measure the amp using 1 metre of wire.
That's really complicated.
Alternatively, an amp can also be measured as the amount of charge passing through a point in an electrical circuit per unit time. 6.241 times 10 to the 18 electrons, or 1 coulomb per second, equals 1 amp.
The candela is the SI unit for luminous intensity. It is the only SI unit based on human perception, defined by a frequency of light with a specific power from one angle.
The definition states that the source emitting monochromatic radiation at 504 times 10 to the 12 Hz is used, producing a radiant energy of 683 watts per angle of steradian. So there you have it, the SI units. They're a bit complicated, but now you know.